J.J. or Joseph John Thomson was best known for two things. First was his idea of the structure of an atom, and second was his experiments with cathode ray tubes. Through his 3 cathode ray experiments, J.J. Thomson concluded that the atoms of cathode rays were made of smaller particles called corpuscles, which we know as electrons, and that those gave the ray their negative charge. He also believed that these corpuscles were surrounded by a positively charged cloud, and Thomson's atomic model consisted of electrons surrounded by a soup or cloud of positive.
In 1909, Robert Millikan, working at the University of Chicago, succeeded in measuring the charge on the electron. He allowed a fine spray of oil to settle through a hole into a chamber where he could observe their fall. The top and bottom of the chamber consisted of electrically charged plates. He introduced a source of X-rays which can cause creation of charges when they strike matter. Charges produced by the X-rays attach to an oil droplet, producing one or more charges on the droplet. When there is no voltage applied, the fall of the droplets is determined by their mass and the viscosity of air through which they fall. When a voltage is applied, the droplets that have a negative charge will fall more slowly, stop falling, or even rise, depending on the number of charges on them. By adjusting the applied voltage and observing the droplets both with voltage off and voltage on, Millikan was able to determine that the charges on the droplets were all multiples of a smallest value, 1.6 times 10 to the minus 19th coulombs. He took this to be the charge on a single electron.
In 1910, Rutherford and his co-workers were studying the angles at which alpha particles were scattered as they passed through a thin gold foil. Most of the alpha particles passed through undeflected. However, a few were found to be scattered at large angles, some even back in the direction from which they had come. This meant that they had collided with an object much more massive than the alpha particles themselves, yet so small that only a few alpha particles encountered them. This atomic level view shows what is happening. Most of the atom is occupied by the low mass electrons. The nucleus is small and massive. When an alpha particle encounters a nucleus, it is scattered at a large angle.
In 1913, a Danish scientist by the name of Niels Bohr improved upon Rutherford's model of the atom. While Rutherford proposed that negatively charged electrons were held in orbit by the positively charged nucleus, he did not describe the location of the electrons. Niels Bohr proposed that electrons move in orbits around the nucleus, and he proposed that these orbital paths, or energy levels, are located at various distances from the nucleus. Today, we refer to Bohr's theory as the Bohr model of the atom.